All right, welcome back. 5.2 notes, activity 3. It says work with a partner. Find the ratio of pitchers of lemonade to pitchers of iced tea. So let's count them up. Let's count lemonade first. 1, 2, 3, 4, 5, 6, 7, 8, 9. There are, over here, 9 lemonades to 6 iced teas. So as a ratio, we would write that as 9 to 6, or we could write that, and I'm going to insert an equation, as 9 lemonades to 6 iced teas. Okay? All right. Letter B. How can you divide the pitchers into equal groups? Is there more than one way to use your results to describe the entire collection of pitchers? Well, in order for me to do that, I have to pause this video to get my drawing tool out, and then we'll just start drawing on this and see what we can come up with. Okay, we're back again drawing. I have my drawing tool out, and my drawing tool makes my little face go away over there. But that's all right. You guys can live without that. So, yes, we can split this into one big group of 9 to 6. Okay. Or we can split this, and I'm going to change the color. I'm going to turn it to red, into 2 iced teas and 3 lemonades. Okay. So here we have 2 iced teas. Oops. I need to pause that again. And nope, wait, erase right here. Oh, it all went away. All right, so we had this group, and then we can create this group here, and then we can create this group here. And all of these have 1, 2, 3 iced teas and 1, 2, 3 lemonades and 1, 2 iced teas. So, in order to get my okay, so now I have my ability to type back, and you know that because my face is here. So this is what we can do. Divide the pitchers. Oh, my drawing went away. Oh, that's all right. Divide the pitchers into equal groups. Is there more than one way? Use your results to describe the entire collection of pitchers. Okay, so we can describe this as, and I'm going to put in a new equation. We can save it as 9 lemonades to 6 iced tea. Okay. Or we can, and I'm going to insert a new equation, we can say that this would be 3 lemonades to 2 iced teas. Now, mathematically, I want to point this out that if we take 9 and we divide that by 3, what do we get? 3. So 9 lemonades divided into 3. You remember we had 3 groups. We had one here, we had one here, and we had one kind of taking up this space in the middle. So we had 9 lemonades and 6 iced teas, and we can split that into 3 lemonades and 2 iced teas. But specifically, we would have 3 groups of, insert equation, 3 lemonades to 2 iced teas. Okay. It must not like that I'm making it plural. 2 iced teas. All right. Now it says 3 more pitchers of lemonade are added. There is more than one way to divide the Is there more than one way to divide the pitchers into equal groups? Explain. Well, let's go back here. What I'm going to do, and this goes up to before, is now I'm going to create a table. So I'm going to go to Insert, Table, and I'm going to make this ratio table here. All right. So we have original 9 lemonades to 6 iced tea. And then we added +3. +3 lemonades. And so now we have a table of 12 lemonades to 6 iced teas. Well, I'm going to add more. Insert column. I got to move my face first. Insert column right. Okay, so how can we rewrite this? We can rewrite this as, well, we would have this group of 1, but we could rewrite this as 6 lemonades to 3 iced teas. Is there another way that we could rewrite this? I think we could, that was divide each of these by 2. We could divide each of these by 3 still. So I'm going to insert another column. It doesn't like the S on iced tea. Well, it also doesn't like them being crammed together apparently either. So now I could take this and I could divide this by 3 and I would get 4 lemonades to divide this by 3, 2 iced teas. So, once those 3 more pitchers are added, is there more than one way to divide the pitchers into equal groups? Yes, we have group 1. And I'm just going to go ahead and change the color of this group to, where's my color fill? To light blue. And then we have another group. I'm going to change this to medium blue. And then we have a third group, and I'm going to change this to dark blue. So once we added those 3 lemonades, we could change this into 3 different groupings. The original and 2 new ones. Part D. The number of pitchers of lemonade and iced tea are doubled. Can you use the ratio in part B to describe the entire collection of pitchers? Explain. Part B. Okay, so yes. So now we no longer have 9 lemonades to 12 iced teas. We now have, insert equation, it's doubled, so we now have 18 lemonades to 6 iced tea. Okay. Can you use the ratio to describe the entire collection of pitchers? Okay. Yes, we can use that ratio for every, we'll go back up to this, 3 lemonade pitchers. There will always be, we'll go back up to this, 2 ice, why is my face in the way? Get out of the way, face! 2 iced teas. So we can double it like we did here. We can have it, or divide it by 3 like we did here. We could double it again. We could have it. No, that would get us back to here. divide it by 3. Oh, we could divide this by 6, and that would get us back to here. Okay? So can you use the ratio to describe the entire collection of pitchers? Yes, we can use the ratio. For every 3 pitchers, there will always be 2 iced teas. All right. And let's delete this, make some space here. What is your answer? In your own words, how can you find 2 ratios that describe the same relationship? Okay, so we have 2 ratios, 12 lemonades to 6 iced teas, and 3 lemonades to 6 lemonades to 3 iced teas. Those are 2 different ratios, but they're the same relationship. They both describe 9 to 6, or I'm sorry, they both describe this basic one here. Oh, we could have divided this by 2, even, or by 6 even. That would have been 2 to 1. How do I want to say this now? How can you find 2 ratios to describe the same relationship? We can use 2 ratios to describe that each one is going to have the same relative number of parts. Let me put that back into a picture so that it makes more sense. That means that I could take 9 lemonades and 6 iced teas, and that will be equal to equation 3 lemonades to 2 iced teas. Okay, 2 different ratios, 9 to 6 and 3 to 2, but they're the same relative value. All right, I was going to try to combine this into the 5.2 practice, but let's stop this video here and we'll create a 5.2 practice video in a matter of minutes. See you soon.